Hi, this is Jason with Tormach. We've got a little project video for today. Let's make a spinning top using our conversational profiling and some stainless steel. I went ahead and drew up a design in SolidWorks. I created a print with all the dimensions that I'll need. So let's get this thing programmed up and let's make this. So on my print here, I just split it up into two different sections. I just did my Op1 dimensions and my Op2. So we'll just go ahead and we'll just start programming Op1. So we're going to use tool number 2. Our tool geometry on this is a 35-degree diamond, so let's verify this quick. On the tool geometry page, you can see we have our 3-degree clearance angle because we're at minus 87, which gives us 3-degree clearance. And then we have 35 degrees is the difference between our front and our back angle. So that defines our insert. And we get the little preview up here on the tool geometry so we can make sure we have an appropriately defined tool. All right, so we'll start getting this programmed. The first thing I'm going to do quick is just get my speeds and feeds set so I don't have to worry about them later. We're running 304 stainless steel, so we'll run it at 350 surface footage. We'll go ahead and let our max spindle RPM be 2,500. We'll do a pretty light roughing pass on this. We're taking real light cuts. It's a pretty thin little part when we're finished up, so we don't want to be too aggressive with it. So we'll go about a 7th thou chip on roughing, and we'll do about a 3 thou per rev on finishing. Then we'll go ahead and set our roughing depth of cut. We'll just do a 20 thou with a 5 thou finish pass. And we'll let it take 2 finish passes just to clean this thing up. So now we can go through and we can start putting in our profile points. This part we want to cut right down to center, so we're going to go ahead and start right at 0. Then we'll start entering our numbers from our print. So my first diameter is 200 thousandths and it's at a negative 75 thou. And we'll have a minus 1/4 inch radius on that. And you can see as we're working through, we have our 1-inch stock defined, and it's going to create that profile as we work through this. And actually we need to make this value at 0.25. My little indent on this is at 200. So we'll change that quick to up to a 1/4 inch, and then we bring this diameter back to minus 0.200. And that's just a straight section. And then we come down to 0.2, and that comes back to minus 0.25. And then we bring it back up to the 1/4 inch diameter at minus 0.3. Oops, put it in the wrong spot there. Let's edit that quick, minus 0.3. We'll delete that, hit enter again. And then we go back at the same diameter. We go back another 150 thousandths to 450. What I'm doing is I'm just giving myself a little bit of a flat and a little cylindrical surface so that when we flip this part over, we have something to chuck it on. So I just want a nice little straight section so we can fixture it for the second side. And from here we come into a nice big curve coming to the top. So this goes up to a 900 thousandths diameter and comes back to 900 thousandths. And we have a 475 radius on, or 474 radius on there. And then we have one more dimension we need to enter, and that's 0.925 is our diameter, and that comes back at 0.925 as well. Then anytime we create a profile, we always want to have our profile exit the stock. We're trying to create kind of a closed curve here. So I'm going to go ahead and just push this back a little further on Z. We'll just go back, to a minus an inch, and then we'll bring it back out to an inch. We're just kind of creating a little bit of a turn so we get a nice cleanup on that angle and just some clearance there so we can get the profile cleaned up and out of the stock. It just helps the software create the roughing strategies and stuff correctly. So as we have our stock diameter, tool clearance, we have at 50 thousandths. We have stock in Z. We have it set to 0, which is fine. We have the part faced off and ready to go. And our tool clearance diameter is at 1.1 inches. So at this point we can go ahead and post this to a file. So let's create a folder quick so I can keep my programs organized called spinning top. Hit OK. And we'll put our folder, our programs in here. So you can see if we zoom in a little, you can see we have our roughing strategies. Got multiple depths of cut, and we have a couple finish passes there. I'm going to go ahead and improve this thing out. So I'm going to turn my feed rates, my max velocity down to 0. I'm going to hit cycle start, and I'm going to just drive this thing over to the part to make sure we have our 0 set correctly and everything looks appropriate. Now that we've reached the end of the rapid motion, our feed rate's still at 0, so the program's waiting for us to jog our feed rate override over. So it is stainless steel, so we can't be too conservative with it or we'll work hard in it. So we got the first side done. Everything looks nice. The surface finish looks really good. The part ran well. It sounded nice. The chips looked good. We didn't turn any colors or anything, so we're still being conservative enough that we shouldn't work hard and run into any issues with this. So we just need to part off. We just need to part this off, and then we'll be able to flip it over to run the second side. So let's create a quick little parting program. Let's jump over to the Groove and Part tab. We'll switch over to the parting. Tool 8 is loaded up as our parting tool. My start Z position. The overall length of this part is 1.3 inches. So I want to give myself just a little bit of cleanup stock for the second side. So we'll go ahead and set this at minus 1.320. Give us about 20 thou stock to clean up on the second side. We're going to take our initial diameter as a 1-inch part. We're going to cut it right down to 0. On this, I'm not going to do any pecs or anything. The tool width we're using is 120 thou wide grooving tool. It's a GTN3 insert. And I don't need an edge break on here since we're just cutting off a blank and we're going to rough it all off on the next op. So I'm going to go ahead and slow down my surface footage a little bit on the parting tool, and I'm going to slow down my max spindle speed. I don't like to run them really high when I'm parting off. I just don't like the parts flying around the machine, so I typically slow down my max speed on a cutoff routine to somewhere around 1,000 or 1,500. It seems to work pretty well for me. So we've got our cutoff. We'll go ahead and post this out. Real simple toolpath display here, just cutting a straight line. So we'll go ahead and let this run, improve this one out quick. So we'll do the same thing again, feeds and max velocity at 0. Pick up our part here, get it wiped up. There's our op 1 part. So I'm going to run a couple of these here just to work through so we have some extras floating around, and then we'll go ahead and flip to op 2. So in the MDI line, I just typed in G0Z.01. So I'm going to send it to 10 thou in front of 0. And then I'll just bump out my stock and use my parting tool as a bump stop. So just loosen my chuck up here and just slide my stock out against my parting tool. You want to be a little careful. You don't want to bang them into the inserts, and you can pop the inserts out of the holder if you hit them, or you can chip them. So just kind of be real gentle, bump it against the insert, and we'll snug our chuck back up. And we'll just jog it away from the part. Then I'll take my 2 programs that we've created and we'll append them together so we have just a single program so we can run a few of these without having to switch programs. So we'll go back to our File tab here. We'll jump back into our folder. Let's take these 2 programs we've created. So how we do this is I'm going to select the first program I want in the list. I'm going to hit the Conversational Edit button, and then I'm going to say Insert a File. So this allows me just to select another one I want to put in. So I'll select my cutoff and adds it to the list here. So what it's going to do is recompile this as a single program with the 2. If we do put them in the wrong order, if we get multiple programs in here, we can rearrange them. If we select them, we can say move up, move down, and we can reorder as we need. So I'm just going to go ahead and save this as, we'll just call it op1. So now I have a new program with these 2 programs all combined in it. If we want to edit, if we want to make any changes, speeds and feeds change or anything, we can still edit these individually by coming in and saying conversationally edit, and we can still have all of our values here. So we can still edit all the programs even though they are appended. We don't really have a need to edit this. We're just going to put them together here, select this as our program and load the G code. So you can see now we have our roughing and finishing routine with our part off, and our stock's been pulled out. So we can go ahead and run this again. Since it has been appended, I'm going to run it like it's a new program again just to be on the safe side. And you can see there we had an insert. We broke the tip on our insert. So I'll jog this turret out of the way here, get it into a safe position. I'm just going to switch tools to run tool 2. So I usually go tool 4 should do it for us. Tool 5. So you can see the insert and see what happened. You can see we just chipped the tip of the insert off. When it was cutting, it did sound like the chip was a little aggressive, so it's probably just, it's a finishing insert that I have installed in there right now, so it's probably just a little bit too much chip load for that chip breaker on here. So I'll go ahead and grab a new insert here and get this thing switched out. And then we'll have to adjust our feed rate and slow it down a little bit to get a little better tool life. Anytime you break an insert or anything, you always want to make sure you inspect your tool holder itself, that you don't have a little bit of swell or raised area up on the edge of that in the insert pocket. So we'll just grab a little stone in a file or something and just make sure they don't have a burr. So we'll jump back to our file. We'll grab our combined program here of Op1. We'll go to our conversational editing. We'll grab our OD program and we'll just hit conversational edit. Instead of 7 thou per revolution, I'm just going to back that up to about a 5 thou. So let's make that quick little change. We'll say finish edit. We'll save the program and we'll hit close. Since it is loaded, it's going to ask if we want to reload the program because it sees that there's a change. We'll just say OK, and we'll be able to just rerun this program. So go ahead and cycle back through this here quick. And this insert is sounding a little nicer. It's just not quite as aggressive of a cut, and it's a more stainless steel specific grade, so we should get some better results with this tool. Sometimes you try to just get something made and you don't want to take that 2 seconds it takes to change an insert, and then you get reminded that it's worth changing the insert. All right, so we've got a few of these parts ran off. We'll go ahead and get Op2 programmed, and we'll get some of these things finished up. For Op2, I'm going to switch coordinate systems in case I want to run some more later. I don't want to have to reset my coordinate systems up every time. So to do that, I don't want to change my X value. So what I did was I sent the machine to just X 1 inch. So then I'll switch to my G55. And since I haven't used this one yet, now I can just come over here and say 1 inch. Quick, easy way to set X the same on both coordinate systems. And then I can bring the tool over and touch off the front side of my part. We cut these off at 1.32 inches. So we'll just jog over to the front here and we'll just touch the face off and we'll set that as our 0 position. I'm just bringing it over till I lightly scratch that surface. So we'll go ahead and set the face of the part again at 0. So then let's jump back to our conversational here. We'll go back to profiling. Let's go ahead and clear this off. We'll go ahead and back up our surface footage here to about 300 just to get a little better tool life again. And then we're going to soften up our roughing feed per rev as well. Then we'll go ahead and we'll just work through this again. So we're going to do the same. We're going to start down at 0. My diameter is at 0.355, and then my Z is at minus 7 thousandths, 0.074, and I have a radius on that of 25 thou. And we've got a status alarm here saying our radius must be larger than 88 thou and 9/10. I must have typoed some numbers here. Let me look at it quick on my print. 120. This is supposed to be 35 thousandths, not 350. All right, so you can see we got a little bit of a line there, starting to show our profile. So our next point is at 120 thousandths, and at minus 50. And then we go straight into our big radius on this side. So this takes us up to a 900 thou diameter again at a minus 0.35 with a 400 thou radius. And then we go back to that same on the other side. We did 925 at minus 0.375. Then I'll do the same thing I did on the other side again. I'll just carry this back. I'll go back to 0.4 and I'll just go up to that 1 inch just to close off that profile so we can get our toolpath created. So there's our second side. Nice simple little one. On this we need to really be gentle. We're hanging on to a real small 1/4 inch diameter, so we're going to take real light depths of cut on this just to get this part made. So we'll take it down to like a 10 thou depth of cut. And we'll even lighten up our finishing pass a little to about 3 thousandths just to, we really want to be gentle on this part. So we'll rename our program here quick, and we'll go ahead and post this off. So you get quite a few passes on this one. So we'll go ahead and just jog the machine out of the way here, and we'll get this thing running. So go ahead, as always, I'll turn my feed rate and my max velocity down, and I'll go ahead and hit start. And what I forgot to do was change my work offset, so I'm still set to G55, so we'll just make another quick edit here. We'll say we had G55, we'll go ahead and repost this program one more time. And then we'll hit reset and cycle start again. That's looking a lot better. So we'll go ahead and just set our max velocity up here a little bit, and we'll start letting this thing cut. So it sounds pretty nice while it's cutting. I can't see any visual deflection in the part while it's roughing. So I don't think we're being too aggressive on it, but we'll see how it works out. This thing's just finished up, so let's get it opened up here and take a look and see how it turned out. The surface finish came out well, but I think it looks pretty nice. So we'll go ahead and take it out of the machine here and give it a test spin and see how it works. Blooper footage. Well, we've got our spinning top all wrapped up. I hope you guys enjoyed this little project video. Feel free to follow along, change it up a little bit, make it the design your own, and have fun making one. Thanks for watching. Feel free to watch our other YouTube videos here and subscribe to our YouTube channel here.